Sir.
Okay, so you are not able. Is it for late registration?
Yes, sir.
Yes, sir.
Oh, okay, no problem. I have already uploaded the materials in the ELMS and also in the Google Drive. So please go through that. What we have discussed about the course outline and marks distribution, and then some rational objectives and learning outcomes of this course. And then we have discussed about the lecture plan. I have already specified all the class test dates in the course outline. And then the type of class test will be online or offline. You know what is offline? I will upload the question. You will download the question, give answers in the blank sheet, and then scan and upload as a single file. I think you are all are aware of that. But for the online quiz, the quiz will be held in ELMS. This will be mostly multiple choice questions, matching questions, and then maybe some short questions, essay type. You have to write in the text box, but that may not be more than 3 to 4 lines of text. We'll take 5 class tests, and then we'll take base 3. We'll count base 3. Our first class test will be on, is it 7th March? I think it will be in the 7th March. That is in our 4th lecture. That is coming Sunday. So let us make sure that our first class test will be class test number 1, that will be held on next Sunday. Let me confirm. We have a course outline that is already uploaded in the ELMS. So those who missed the first class, please go through ELMS documents and see. We have our first class test on 7th March, and 7th March will be our 4th lecture. So today is our 2nd lecture. There will be another lecture on next Wednesday, and then in the coming Sunday we'll have our first online class test. The class test will be online. So class test 1, that is online, it will be online. So online quiz treated as class test 1 on next Sunday, that is 7th March 21, during class. Okay, it will be exam duration. Exam duration will be 20 to 25 minutes. And then syllabus. Syllabus will be section 1.1, section 1.2, and section 1.3 of chapter 1. That we will cover today. And type of question will be, type of question, it will be mostly MCQ. There can be matching questions, that is matching the left side to the right side. There can be true false type questions, and some 1 or 2. It is not necessarily there must be 1, maybe not, but there can be at most 1 or 2 short questions where you have to write maximum 3 to 4 lines of text. So that is the idea about the type of the question and type of the exam. Okay. Okay, so this is about our first online class. Yes.
Sir, question uploading and downloading is include 20 to 25 minutes.
No, there will be no question uploading, downloading. See, this is online. Online means the question will be in the LMS. So you will log in and then you will just start the exam, and all the questions will be multiple choice type or true false type or matching type or short question that will be entirely in the LMS. You don't need to download anything. You don't need to upload anything. When I say, okay, this class test will be offline, I can take some offline class test, maybe when I think your answer should contain some diagrams, some text. But for every class test, I will ensure whether it is online or offline. Okay. So our first class test will be online. So you don't need to download the question. You don't need to upload the answer. It will be completely on the online. You will submit and it will be automatically graded or submitted. Okay. Is it clear?
Okay, sir. Yes, sir.
Okay. Okay. So first class test, no need for downloading and uploading. Any other question before we start today's class? Okay. Today I will cover section 1.1, section 1.2, and section 1.3. That is from chapter 1. You can see I have also uploaded a study guide, right? This PDF is already uploaded. But what I said, this study guide is prepared as a guideline. It is not as a replacement of a textbook. So you must read the textbook to understand the concepts. And most of the time our question will be conceptual. So if you don't understand the basic concepts, it will be tough for you to answer. So this study guide will guide you. How? Let me explain how. So students must read the textbook to have the required understanding for the exams and other evaluations. And this workbook is based on the textbook that I have mentioned already. It is 7th edition is available now. So you should collect 7th edition. And then in this workbook, I have put some examples, exercises, figures from the book, so that we can use it as an exercise book. And also there are some animations or videos in the textbook companion website. I will give the link in the LMS after today. So you might have some examples there also. Okay, so this is chapter 1. And for chapter 1, we will have all the subsections listed here. Section 1.1 to section 1.5. There are 2 other sections, section 1.6 and section 1.7, but that will not be covered in this course. So basically we'll cover 1.1 to 1.5. And today's class will cover 1.1 to 1.3. So 1.1 describes what is internet. Then 1.2 describes a structure, a part of the internet that is called network edge. We'll go through details just a little bit later. And then section 1.3 describes the network core. What is network core? I'll explain shortly. Section 1.4 is some performance parameters in the network. And then section 1.5 is protocol layers and their service models. I think you have some idea in data communication course, the computer science students, and also in communication theory, those who are from Tripoli department. So I think we have some idea about section 1.5, but in this course, we will again cover these protocol layers in detail so that the concepts will be easier for us to understand. But today's class we will cover only 1.1 to 1.3. Okay, how that will be helpful for you? See, I have put all the figures. The figures I have used in the workbook is from the textbook. So you can connect your workbook to the textbook. For example, you know, I have covered figure 1.1 in the class, but there is no text here. All the descriptions are in the textbook. So when you read the textbook, sometimes you have difficulties, right? There are so many texts, so many pages we have to cover. We don't have enough time. So my suggestion is follow the guidebook, follow the workbook, find what are the figures, and then try to understand the concepts of the figures only for those figures in the textbook. So in that case, you can read the text selectively. Is it clear? So it will help you to find out which part in the book you should read. So if I don't cover anything in the workbook, then you don't need to read that part right now. If you are interested, you can read, but that is not mandatory. Okay to everyone? So that's how I have put the materials in the workbook, and also there are some exercises we will do time to time in the class. Okay, let us first start with some diagrams. It is also from the textbook. So you can see just okay, let me first go through one basic idea. Okay, what is internet? Can anyone tell me what is internet?
Sir, internet is basically connected all the component on the web, like the computer, mobile, IoT devices, and in the different places.
Very good, Ishtiaq. That means connecting all the device as a single network, right? Right, that is internet. And in the first class, I have shown you one simple example that we use every day, right? Web browsing. So using that example, I have shown you actually internet is nothing but a connection of huge number of local area networks. So whenever we connect to internet, we connect from a device, and definitely that device is part of a LAN, right? And when we connect to another host, another server, another device, that destination is also part of another LAN. So what is in the middle? In the middle, there are the infrastructure, the connections that we call wide area network. So internet is an infrastructure that actually connects all the LANs. That means the users in a particular LAN are able to communicate with others in the other side of the world, in other LANs. But to understand it much better, we have to see, we have to classify the different ways what is inside the internet, or how we can characterize internet. Okay, so in that view, the first thing what we do, we can see the internet from top. Like you can take pictures of the world from the galaxy, right? From the moon, from in other places, from the satellite. You can take the pictures. That means you are seeing the earth from top. Similarly, if we see internet from top, we can classify internet into two views. Very simple, very simple. One is called nuts and bolts view. That means, like what Ishtiaq has answered, it is a connection of different components. That components might be devices that we use to connect to internet, like PC, laptop, smartphone. But that components might also be some devices that as a user we don't use directly, but they are used to connect the end devices, the user devices, like hub, like switch, like router, right? So I think most of you are doing computer network lab also, so you have some idea about hub, switch, and router. If you don't have some idea, actually time to time we will make it clear. But nuts and bolts view is like if we remove some nuts and bolts from a machine, what we get? Different components. So similarly, we can see internet from top as a nuts and bolts view. That means internet is a collection of hardwares like end device, PC, laptop, smartphone, or intermediate devices like hub, switch, and router, and also a collection of software. What is software? We know programs like operating system, Windows, Linux, like our web browser, like a protocol, that is HTTP, right? So internet is a collection of different hardware and software components. So that is one way we can see internet from top, nuts and bolts view, right? The second class, the second type that if we can see internet from top is service view. Irrespective of connections of hardware and software, I can tell you, like, okay, what is internet? Internet gives us, internet enables us to send emails, right? Internet enables us to browse websites. Is it correct? Internet enables us to talk over Skype. So the second one, we can categorize internet is as a service view. Okay, when we say service view, there can be two types of services. One is reliable, one is unreliable. Reliable means no data loss is tolerable. That means, for example, if you download a file, and if the file is downloaded very fast, but 10 bytes are missing, is it okay? Will the file work?
No, sir.
No, sir.
No, sir.
Even if you miss a minimum number of bytes, it will not work. So that is where reliability is important. For file transfer, we want 100% reliability, even if I get it at the cost of some more time, some more delay. Okay, so that is reliable service. What is unreliable service? For voice communication, for multimedia, video streaming, some data may be lost, right? But delay is not tolerable. So data loss means if some data are lost, it can still work. Some like sound is some noisy sound, but we can understand the conversation fine. But if delay is beyond a particular level of acceptance, then it will not work. So we can see internet as a service view where two types of services are there. One is reliable service like file transfer. One is unreliable service like voice communication or multimedia or video streaming. So that is one view when we see internet from top. Any question? Okay. So if we go to now the diagram now, so you can see there are lots of devices. There are laptops. Okay, even if a fridge is there, a thermostat is there. Now you know IoT, Internet of Things. So many devices even in my home is connected to internet. Then it can be a smartphone, even it can be a vehicle. Now vehicles can be connected to internet. Then PC and many other things, our tab. Okay, so these devices, those are used by the users, called end devices or host. Is it okay? End devices. So what are end devices? Those are used by the users. But there are other devices that actually connects the end devices. Like you can see in the diagram, router, right? These are the routers, the blue marked devices, routers. We have to know that if we want to connect devices in different networks, we must have router in the middle. But when we connect devices in the same group, same network, then we can use switches or hubs or wireless router like this. But even switch, wireless router, hub, all are part of the intermediate devices. Why these are called intermediate devices? Because they are not normally used by the end users. They are used in the middle They are used in the intermediate infrastructure to connect end devices. Okay, so from top we can see, okay, nuts and bolts. That means you can differentiate end devices, intermediate devices, and also softwares. And you can see as a service where we can transfer files, we can browse websites like this. That is one way of defining internet. Okay, two types of top view. Now, another thing is a protocol. Okay, what is a protocol? What is a protocol? Give an example of a protocol. Anyone?
স্যার আমরা যে সিম্পলি স্যার
Okay,
মেইল
sir.
পাঠাই স্যার, আমি একটা মেইল পাঠালে আপনার কাছে যাচ্ছে, এটা
Right,
একটা প্রোটোকল।
right,
এটা তো আপনার কাছে নাকি অন্য কারো কাছে যেতে পারতো।
right. So why that is only sent to the particular destination? Because that is defined in the protocol. So protocol means, so in fact email itself is not a protocol. Email uses some protocols like SMTP, but most
Yes, sir.
common, I think all of us has seen many times, what? HTTP, right? Hypertext Transfer Protocol. Whenever we browse anything, any website, on the left we get HTTP. Is there anyone who did not see HTTP? Anyone? No one.
No.
Because we all use web browsing, and just keep the eye open. Now we are in the course of computer networks, so we should be an expert at the end of the course. So if anyone asks me anything about computer network, at least basic concepts, we should be able to answer that. Just keep your eyes open. So whenever you say anything, just connect to your contents in this course. Okay, so HTTP is one example of protocol. Now, generally, what is a protocol? Actually, when we meet some unknown person in the road, maybe for some reason I want to ask some direction to a destination. Maybe I forgot the path, so I ask someone to okay, how can I go there? So before, or I ask someone, what is the time now? If the person is unknown to me, what do we say? Hi, hello, excuse me, right? If we don't say something, that means we are not that much gentleman. They're not polite. So it is a protocol. We say hi, then we say, okay, what is the time? We say, excuse me, then we say, can you tell me? That is the protocol. So that's a human protocol. But if we don't say hi, right? When you call your friend, you say hello. Why? If you don't say hello, will it work? Yes or no?
No, sir.
It will still work because
Yes,
we are
sir.
human. We maybe I say, okay, why we say hello? To make sure the other side is ready to receive my data, right? That is the idea of hello. So this is protocol for, there are so many examples where we use protocols. But in case of machines, similar thing, the protocol defines how the things will work. Okay, now any protocol, HTTP or also IP address. IP means internet protocol. We will study TCP, transmission control protocol. So without protocol, network will not work, machine will not work. Simple. So generally what a protocol contains? A protocol contains something related to messages. Why messages? Because during communication we exchange messages, right? Like I said in the previous class, if Bangladeshi says something in Bangla, a Chinese will not understand, right? Similarly, the vice versa will understand. But if both talks in English and both knows English, then it's okay. So we are sending information. Bangladeshi is saying in Bangla, Chinese listens but don't understand. That means we are sending information, but that is not message. Message means that should be understandable to the other party. So anything we do during communication, we exchange messages. That is the bottom line. Okay, now in case of machine, what will be the format of the message? What the receiver will do after receiving the message, it must be defined somewhere so that we can program and then machine can work, right? So 3 keywords you have to keep in mind. When you say what is a protocol, protocol is defined by 3 keywords: format, order, and actions. What is format and order? Format and order is about the message. For example, in English, we say, I eat rice, right? In Bangla, what do we say? Ami khai bhat, naki ami bhat khai.
Ami bhat khai.
Right? So in Bangla, it is different. In English, it is different. But every language, every message has its own format. Similarly, when there is a communication in network, you must define how this can be communicated. And the first thing you have to define, what is the format of the message? That means which, like subject first, then verb, then object, right? In English. So similarly, that is the format, and that is also the order. Because if I put verb after not followed by the protocol. So format and order is related with message. Which fields will be there and which field will come first, which field will come later. That is format and then order. And one is actions. What will be done after receiving the message? So just 3 keywords will define any protocol. That means protocols must define this. So you have to keep in this, remember these 3 keywords, then it will understand what is a protocol. Okay. Now, section 1.2. Okay, before going to section 1.2, we need to, now previously we saw internet from top, right? And then we say, okay, there are 2 categories. One is nuts and bolts view. One is service view, when we see from top. But now we want to go a little bit more in depth. When we go to in depth, we can categorize internet into 3 different parts. See, one is network edge. Now we are not seeing from top. We are going inside internet and we are separating different structures. First one is network edge. Network edge contains what? End systems or hosts. Now, what is significant in network edge? Can anyone tell me? When we communicate,
Sir, can you say the question again?
what is significant? What is the point? What is the interpretation of network edge? We tell that network edge contains end systems or hosts. Okay, that means what? That means from one end system to another end system we communicate, right? So
Yes,
if
sir,
I
exactly.
if I say you, okay, then we always, as a user, we always use internet from network edge, and we connect to the device also in the network edge, correct?
Yes, sir.
Okay. Now, second one is network core. Maybe one end system is in Bangladesh, one end system is in USA. Definitely, they are not directly connected with an wire, right? There must be some infrastructure in the middle. I gave you some idea in the first example, in the first lecture. So that infrastructure or that backbone in the middle, now we can call it network core. So network core will contain intermediate devices. Now, intermediate devices and end devices. So now you can see this. Can you understand? So if we just circle all the end devices in a group, we can call this network edge, right? And then
Yes,
if
sir.
we circle all the intermediate devices, then we
That
call
was
that
network core.
network core. Very simple. Okay. So this is actually mutually exclusive. Intermediate devices will not be network A's. End devices should not be network, but there are some exceptions. We are not worried about that right now. So in this diagram, we can easily find out what is network core, what is network A's. Is it clear to everybody? And
Sir,
throughout
I have a
this,
question, sir.
okay, sure.
Sir, as per your decision, so is the router is a network core in our home?
Definitely. In our home, in the middle, always routers are in the network core. Only your end system will be part of network A's.
Okay, sir. But sir, rather than sir, whenever we connect our router from the pole of internet, so that time there is also a core. So router is a core, and also the bigger upper station or middle station is also a core.
Yes. Okay. Make it simple. What is A's? A's means like the A's of a table. What it means? It's at the last end, right? There is nothing
Yes, sir.
after that. There is nothing after
Yes,
that.
sir.
So there is nothing after the end device. So that's why end device is part of network A's. But if there is a device like you have used hub, you have used wireless router, you have used switch, but they are connected to another router, no problem. But is there any other device after that? Yes or no?
No, sir.
Is there any other device after your router, after you switch?
Yes, sir. Yes,
At
sir.
the
Obviously,
end?
sir.
Yes.
There are so many
Yes.
devices.
Yes, so that means that is an intermediate device. Just think this way right now. Very simple. If any device is not at the end, that is at the network core. Okay.
Okay.
So just make it simple. All end devices, network A's, all intermediate devices, network core. And now anything we read in this course, anything, any theory, anything must be within network A's or within network core. So keep in mind. Now, these are the two parts. I think this should be clear. But other than these two, there are some other parts. That is C. First one we call physical media. See, in network A's, you must use physical media. In network core, you must use physical media, right? What is physical media? How devices are connected. So A's devices must be connected. That means end devices must be connected. Intermediate device must be also connected. You know what? Our cellular network, mobile network, our smartphone is connected to base station, wired or wireless?
Wireless.
Definitely wireless. And base stations themselves are connected to the upper layer structure through wired or wireless.
Through wired.
Sir,
sir.
wireless.
Mostly it is wired, maybe optical
Wired.
fiber.
Yes.
But it can be wireless sometimes. But mostly we can think about the backbone is wired, and the last mile access, the last mile service is given wireless. So see, you cannot differentiate always it in network A's or network core. Physical media must be everywhere. So that's why other than network A's, network core, in the internet, we give a separate structure, physical media. So it can be wired. We'll not go through very much details here because I think you have in some other course like data communication, communication theory, digital communication, we'll have not enough time to go to physical media. But just get some idea. There can be wired media like coaxial cable, UTP, optical fiber, okay? And there can be wireless like mobile cellular, like Wi-Fi, like some of us use QB, Bangla Line, WiMAX, okay? Satellite, radio link. So there are different types of wired and wireless, but definitely two devices must use some physical media when they communicate. Doesn't matter it is network A's, doesn't matter it is network core. And the last part, that is not a separate part, that is also part of the third structure, that is network access. Now there is a confusion between physical media and network access, okay? We have already considered physical media. So what is network access? Actually, network access means irrespective of physical media, there are different technologies. Like in our UIU network, how many ways you could use internet? Can you tell me? You can go to one of our labs, and then you can use some PC, you can use internet. One way. Another way,
Wi-Fi.
you can use
Wi-Fi.
right, Wi-Fi. So actually there are two ways. One is Wi-Fi, that is wireless LAN. One is wired LAN, that is our labs, right? Machines in our labs. But in our home network, there are many other ways. Like we can take connection, we call broadband, right? Take some connections from the local ISP, wired connection. Also, we can take connection from QB, Bangla Lion, that is we call a WiMAX. Also, we can use 4G modem, right? From cellular mobile network. We can use it in our router also. We can use it in our smartphone. So there are many ways we can use internet. So network access means what are the ways we can access internet? Okay, for example, we can use Wi-Fi. Now make it clear. We used Wi-Fi in the physical media also. We use the term Wi-Fi in the network access also. Actually, Wi-Fi, that means wireless LAN, is a technology. So the technology also uses some physical characteristics, right? Some signaling that is not same as the cellular. Is it clear? So when we say physical media, connectivity is Wi-Fi, that means that is the physical connection of the Wi-Fi. That is the physical signaling of the Wi-Fi. When we say network access Wi-Fi, that is the technology. Like Wi-Fi has a technology, WiMAX has a technology, 3G has technology, 4G has technology, wired LAN has technology. Then anybody use BTCL connection, DSL, broadband from?
Yes, sir. I use, sir.
Okay, so in that case, you have to have that landline, right? You have to have a
Yes,
landline
sir.
from them. So that is another technology, DSL, digital subscriber line. And also there is another technology, not very much available in our country, but it is very common in the outside. That is fiber access. That is the dish connection. We got the dish connection for the TV, but using the same connection, we can get data also. That is called fiber hybrid coaxial, FHC. Okay. So there are different ways how we can use internet. Okay. So now let me review. So if we go to in-depth structure, if we go to inside internet, we can characterize internet, structure internet in three different parts. One is network edge, one is network core, and the third one is physical media and network access. Although physical media network access is different. Any questions so far? Okay, so that is section 1.2. There is one more, I think one more point we have to discuss in network edge. That is, since network edge deals with services, user services, so we can do types of architecture. That means we can divide network edge into two architecture in terms of services, in terms of applications or services. As I said, network edge is mainly what we do in the internet. We as a user use one end system. We as a user connect to another end system. Both are at the network edge. So in this case, there are two types of architecture. One is called, I think many of you heard that, client server architecture, right? So what is an example of client server architecture? There is a dedicated server like web browsing, like email, okay, like FTP. There are many other examples. DNS, where we have dedicated server and then no direct client to client communication. No direct client to, so just simple idea. We'll see that in more details in chapter 2. When you go to chapter 2, we'll go to more details. Just I am giving you the overview of client server architecture. There is another one called peer-to-peer architecture, right? Peer-to-peer architecture. So what is peer-to-peer architecture? The simplest possible example is connecting two PCs. Like at your home, you used a hub to connect all your devices. That is what? Peer-to-peer. Because why you have connected them? Maybe you want to copy files anytime from any device to another device. So there is possibly no dedicated server. In case of web browsing, see, we connect to Facebook, we connect to Google. That means what? That means my browser is the client and Google server is the server. So Google server will never be client, right? But if we create a simple network at our home, connecting my PC, two PCs, or one PC, one laptop, and one other device, then that can be a network, peer-to-peer network, because no machine, no device will be dedicated for service. Anytime, any device can be used as server or client. So this is the idea of peer-to-peer. Any host can be server or client simultaneously. Any example? Any other example? You use torrent?
So torrenting, huh?
Right. So what is the idea of torrent?
So একটা client থেকে একটা client upload অথবা download করে.
Right. So when downloading, the downloading client can also serve as a server for others. That is the idea. For example, if a client downloads a 100 megabyte file, it can download from 10 different sources, 20 bytes each, or 5 different sources, because 100 megabyte, so 20 bytes each. Then when it downloads the first 20 bytes, it can act as a server for other clients. So that is the idea of torrent. It is for parallel computing, and in that case, server is not very much bogged down. So it can be shared by all the peers. So that is one example of peer-to-peer architecture. There are many other examples, but let us stick here just the basic idea of two architectures in network A's. So it doesn't matter whether we use client server or peer-to-peer, that is part of network A's. Any question? Okay, let us now go to network core. Okay, when we go to network core, just get some overview first and then we'll go to details. There are two technologies in network core. One is called circuit switching and one is called packet switching. Example of circuit switching is traditional telephone network, like previously I asked you about BTCL connection. So traditional TNT line, even not only TNT line, mobile, for voice communication during the 2G, even 3G, maybe part of the 4G, although 4G first introduced the idea of all IP network, that means all packet switch network. But before that, the voice part was based on circuit switching. How circuit switching works, just we'll see shortly. And there are different technologies like FDMA, frequency division multiple access, time division multiple access, then code division multiple access. So there are different technologies. Now the packet switching example is internet. So in our course name is computer networks. Computer networks is mainly based on internet. So in this course we will mainly target internet as an example. So this course will be mostly about the internet and that uses packet switching, but we'll have a very fundamental concept on circuit switching maybe in some other courses like mobile cellular communication, digital communication. You might have in more details of circuit switching, but in this course we'll mostly learn about packet switching. So examples: web browsing, email, Skype, torrent, VoIP, so many things. And now there are huge amount of data in the internet. So people are using many applications of circuit switching by replacing, applications of packet switching by replacing the circuit switching. Okay, but basically there are two types of technologies. Let me see a little bit of details now. Okay, so you can see this is circuit switching. So if I just let you know what is circuit switching, I think it is visible, right? So circuit switching is like traditional telephone network. Even if you use in data, it is like telephone. When you call someone, okay, suppose from A, if you suppose this is A, okay, and this is B. So A calls B. Now in circuit switching, what you have to know, the possible number of links fixed. Why it is fixed? Because in case of technology, you heard about FDMA, TDMA. We just divide the resources into pieces. We call each one a slot. So in this example, you can see how many lines between these two? 4, right? Is it visible?
Yes, sir.
4 lines. That means between these two exchanges, between these two switches, there are at most 4 slots or 4 links. That means we cannot connect more than 4 links between these two switches. I think in this example, all switches has 4 links, but it can be different. It can be variable, but doesn't matter how many links there, the number of links are fixed. Okay, now can I ask you a question? Is it fixed in this example? Is it fixed how many connections can be ongoing simultaneously? Is it fixed? Doesn't matter how many connections you can create, but it is actually fixed. So if you have an infrastructure, for example, in the mobile network, Grameenphone has huge bandwidth, right? Huge spectrum. Banglalink has huge spectrum. Doesn't matter how much spectrum they have, if they calculate number of users supported simultaneously, that is what? That is fixed. So that is the main disadvantage of circuit switching. Okay, another thing is, when I call from A to B, there must be a circuit setup. That is where the name comes from. Initially, A will find the first free link to this switch with which it is connected, right? And then it must find at least 1 link free in this way or in this way. Anyway, it can search. Suppose it finds 1 here. Again, it must find 1 between these two. Okay, And then finally, definitely it must find this line from this switch to be free. When at least one link is free between the switches, then we can say that, okay, there is a connection set up between A to B, right?
Yes, sir.
That means a circuit is set up, and only then we can hear the ringtone. So when you call your friend through mobile, you can see that there is a delay, right?
Yes, sir.
When we call and before you see hear the ringtone, and sometimes what happens, you find the engaged tone. That means what? That means maybe somewhere in the link no resource available. Maybe you got here, but here some link is not available. That means circuit cannot be completed. Then you see the sound like all circuits are busy, it cannot be connected right now. Actually, not all circuits are busy. Maybe somewhere you just fail to get one particular slot free, so you cannot set up your circuit. So these are the two fundamental properties of circuit switching, and this is where circuit switching lags behind. Circuit switching has disadvantages, and due to the tremendous growth of internet, due to the tremendous growth of people connecting to the internet, if circuit switching was used in the internet, then long before we have to stop, no more users can be connected to internet. But fortunately, we have packet switching concept started before, and it is very, very popular now. In case of packet switching, the idea is, instead of dedicating a link, okay, another point is, when we find a link for that circuit, and if connection is set up, that particular circuit is set for a particular amount of time. That means the links, the slots are dedicated to that particular connection. So even if the user does not use 100% of the time, right? When we actually send data, maybe we are not sending data 100% of the time. When we talk, we are not talking 100% of the time, right? But if you allocate some link to the connection, that is dedicated. So that is another problem. Okay. Let me explain again. When we say, okay, a circuit is set up, right? And this user is communicating for 10 minutes, for example. During that 10 minutes, this link and this link will be occupied, right? Dedicated.
Oh, yes, sir. Yes, sir.
Yes. And maybe out of the 10 minutes, what percentage of time user is actively transmitting, user is actively talking?
Very
Maybe
little,
8
sir.
minutes, maybe 5 minutes, maybe 2 minutes, maybe 1 minute. It doesn't matter. But the problem with circuit switching is, whether it is 10% time or 20% time, the entire time these links are occupied.
Oh, yes, sir.
Got my point? So that
Yes,
is
sir.
one disadvantage. It is called less utilization. See, number 3, less utilization. So I have also explained 2, fixed users. I have also explained the resources are dedicated. Now, if we go through packet switching, the first thing, resources are not dedicated, no dedicated resource. So it is not based on user. It is based on what? It is based on every user, data will be divided into packets, and then it will just carry packets. And the packets will reach to the destination, and the destination has the responsibility to reorganize and reassemble the packets to get the overall data. So in this case, no links will be dedicated. What is meant by that? So whenever a packet is transmitted, it will use the entire bandwidth. Unlike in circuit switching, where a user gets, for example, there are 4 links. So if I say bandwidth is B, one particular link will get B by 4, right? Very simple. So
Yes, sir.
a user will get partial bandwidth, not the full bandwidth. But in circuit switching, one packet will be sent. There cannot be, you cannot send more than one packet at the same time. But when that packet is sent, it will use the entire bandwidth of, like in this example, 15 Mbps. Okay, we'll go through some numerical examples, so it will be more clear. But now just compare with circuit switching, no dedicated resource. And since we don't dedicate any resource, how many users you can support? Theoretically unlimited,
Yes, sir.
right? Because you're not dedicating any resource to any particular user. But okay, there are some disadvantages. What can happen? Like in our Wi-Fi, right? In UIU, every Wi-Fi, every floor Wi-Fi, there are actually fixed number of IPs given. So fixed number of IPs given means what? Fixed number of IPs given means if number of IPs given is 25, when 25 users are already using Wi-Fi, 26th user must wait, right?
Yes, sir.
Okay. Why that is said? Because if you give more than 25 users, maybe your service will be unsatisfactory. Your transmission rate will be down. Okay, we can make it 50 if we have more bandwidth. So it is like that. If you increase the number of users with that same bandwidth, definitely users will not get 100% service. So that is the problem with packet switching. You might not get 100% dedicated service. That is advantage of circuit switching. Because resources are dedicated, it will be 100% service. But in case of packet switching, if number of users are more than the available resource, then you will have delay, you will have congestion, you will not get guaranteed service. But you have to accept that.
Sir, DSL connection ki circuit switching hai ki packet switching ki duty sir?
Very good question. DSL is packet switching. Sorry, circuit switching. Because DSL uses traditional telephone network.
Okay, sir.
Any telephone network or mobile network 2G, 3G is part of circuit switching. Okay, then definitely utilization will be more because we are not dedicating any resource. So only when needed, then the resource is used. Definitely it will be more utilization. You have very interesting example in the textbook called restaurant reservation. See, when we just plan a program for maybe our class party, maybe for some reason we plan a program, what we do, we can do two things. We can reserve the restaurant. We can talk before, prior to the program. We can just ask them, okay, reserve it from 7 p.m. okay. But when we go, normally we go at 9 p.m. So from 7 p.m. to 9 p.m. what happens? Utilization? Zero.
Full.
That
Oh,
particular reserved part utilization is zero. In terms of system point of view, that is wastage, right? On the other hand, what you can do, okay, I will not ask them to reserve. I will go instantly, okay? That might be good. You go and then you get seat. But it can happen that all the seats are occupied, right? Then what you have to do? Wait for some time. Maybe you will not get. So that is the problem with circuit switching. But from the system's point of view, the second one is actually packet switching. The first one, when you reserve, is like circuit switching. For circuit switching, it is good for us, right? As a user, it is good for us. It is guaranteed. Even I go to 9 p.m., I go to 10 p.m., they have reserved it for us. For packet switching, we go instantly. We might see all the seats are occupied. That is problem for us. We have to wait. But from the system point of view, which one is better?
Packet switching.
Packet switching, because their resources are fully utilized. Even if not fully utilized, the wastage is minimum. So did you get my point? So that is the difference between circuit switching and
Yes, sir.
packet switching. Any question? Okay, now let us see some very simple example, two very simple example. Then I will ask questions from you. If we go to workbook, I think you can also open your workbook. You can take your paper, pencil, okay, and then you can just answer these exercises. Okay, so what are the four? Very trivial. What are the four end systems? Four intermediate devices, two types of services by internet, right? Is there any problem? Is it okay? So just do it yourself. Solve all the exercises given in the workbook before next class so that we can discuss your problems. So do it your own. Again, in exercise 2, what are the three keywords used to define a protocol? Already I have given the answer. List some well-known protocols used in internet. Already I have given some examples like HTTP, SMTP, but there are many other. Okay, network age. Identify. From figure 1.3, identify. Already I have shown you how to identify network age, network core, and 4 types of physical media. You just point out here and then write the name of the physical media, wired or wireless. 4 types of network access. I have given you some examples. Any questions so far? So please complete these exercises before coming to next class. Okay, now network core, we have covered the basic concept. Now what we want to do, we want to do some exercises. So there are 2 examples. FDM. In FDM, what happens? The total frequency is divided into individual frequencies. Each user will be assigned a particular frequency, and then it will be dedicated to that user until the connection is broken. In case of time division, the entire resource is divided into time slots. Now frequency, I think it is clear. For example, 4 kilo. Why 4 kilohertz? Any idea? Anyone? Is there any significance of 4 kilohertz? Okay, no problem. Voice, right?
এতটা হয়তো enough আমি যা ডাটা পাঠাতে চাই
Right. Actually our voice, for transmitting our voice frequency actually 0 to 4 kilohertz maximum.
Oh, sure. Nice.
So that means one channel, it is actually example of a voice communication. So one channel 4 kilohertz is fine. So if you have, for example, 4 megahertz, just divide it into 4 kilohertz each. So maybe you can create 100 or 1000 channels. That is how the mobile cellular network, actually they design their network. This is simple, but in case of time division, we can divide each of these 4 kilohertz channel into time. What is the advantage? 2 advantages. One is we can support more number of users, right? If you divide only using frequency, how many users? Maybe 100. If you divide each frequency again into 4 different time slots, then you can support 400 users. So one advantage is supporting more users, and another advantage is definitely utilization will be less. If you put the cells smaller and smaller, because that is dedicated, so the utilization will be less. Anyway, for time division, in this example, see 1, 2, 3, 4. That means how many users supported? 4 users, right? So 1, 2, 3, 4, then 1, 2, 3, 4, then 1, 2, 3, 4, it will be repeated. And the first user who used 1 will have to wait 2, 3, 4 slot and then come again. The time difference is very small, so it is not realizable or visible to the user. But this is how time division works. In this case, each user will get the lowest unit it will get is a slot, 1 slot. And the 1, 2, 3, 4, it can be not 4, it can be 40. So 40 slots means 40 users, or if I give 2 slots for 1 user, then 20 users. It depends on how many slots I give to one user. but number of different slots is called a frame. So the time domain is divided into frame, and each frame is divided into a smaller units of slots. Is it clear?
Yes, sir.
So if you say, okay, I will give one slot to each user, that means you will this system will support 4 users. If I say I will give 2 slots for one user, this system will support 2 users, right? Very simple. Now let us do one particular example. It will be
That means, sir, one frame is hold all the users.
sorry.
One frame is hold all the users. Like 20 minutes.
One frame for yes, all the users, right. One frame means the number of users we support, all the users will be accommodated in a single frame. Doesn't matter how many slots you give to each user. Okay,
Yes, sir.
every frame will be repeated again and again. Now let us do a very simple example. I think it will be now clear. How long does it take to send a file of 640,000? Please take your pen and pencil and paper. If you do the examples with me, 60%, 70% of your task will be done in the class. If you just think, okay, I'll do it later, then it will accumulate. Okay, my suggestion is, please do it with myself. Okay, a 640,000 bits. That means the file size is 640,000, and we use a circuit switch network, and all links are 1.536 megabits per second. Each link uses TDM. Now, what is TDM? You know, this is TDM. So with 24 slots per second, that means if we say, okay, one user will get 1 slot, that means one user will get 1 slot per second. If we say one user will get 2 slots per second, but if nothing is said in the question, you will assume 1 slot per user. Okay, and then 500 milliseconds to establish the end-to-end circuit. So what we can do, just let me do it this way. Okay, so we can see the information here, and we can do one exercise here. That is exercise 4. So we need to find out capacity per user. How we can find out that? Okay, capacity per user. Sorry, this is here. Capacity per user equals 1.536 megabits per second. That means 10 to the power 6. I am writing in text pad, so I am using these symbols. Is it okay? So I am just converting megabits per second to bits per second. You have to keep in mind all must be in the same format, since what is the size of the file? 64,000 bits. So that's why I have converted megabits to bits. Now capacity per user, how can I get that? If I divide by 24. Okay, Kaushik, are you there? Kaushik?
Yes, sir.
Okay, calculate and tell me what is the value. Just divide this. You can use calculator or your computer. What's the resultant value? Laila Israt, are you there? Laila? If I don't find anyone, you will be absent. If I call and don't find anyone, you will be absent.
64,000 আছে 64,000
64,000, very good. 64,000. Okay, so all agrees?
Yes, sir.
Okay,
Yes, sir.
64,000.
Yes, sir.
That,
Yes,
that
sir.
means 64,000 beats per second. Now, we got, okay, what is the capacity of each user? So what is the file
Sir, I have
transmission
one
time?
question.
Sure.
Sir, would
Name,
you cut
name
marks?
please, Ashrafun, right?
Yes, sir.
Ashrafun, okay.
Sir, would you cut marks if we don't put the units like BPS or something like that?
Actually, I should not say in that way, but I should say you should write the units. You should.
Okay, sir.
It depends, because we always try not to cut your marks. Do you believe that? We faculties, actually, we try not to cut your marks. At least I want. But if some basic mistakes are there, then I have nothing to do without cutting. So it is better. It is not very time consuming. Try to use the smaller details, so that even if you do some silly mistake, I see your process is correct, I will give you maximum marks. So that is why we should write this. Okay.
Yes, sir.
Transmission,
Understood.
file
Hello, sir.
transmission. Yes.
স্যার ওই ফন্ট সাইজটা একটু বাড়াই দেওয়া যায় স্যার, তাহলে দেখতে
Okay,
সুবিধা
okay,
হতো।
okay. Font.
স্যার অ্যান্সারটা কি 10.5 মিলিসেকেন্ড হতে পারে?
Right. Answer 10.5 millisecond. Correct. Okay, file transmission time. Very simple. Actually, I am writing every step to make you understand, but it is very simple. So it's just oikik niyam, right? Oikik niyam. So 64,000, 640,000. It is the file size, right? So it should be file size divided by capacity, right? So it will be equals to 64,000 divided by 640,000 divided by 64,000. That means 10 seconds. Is it okay?
Yes, sir.
So this is only the file transmission time. So total time needed will be file transmission time plus circuit establishment time, right? So it will be 10.5 second. 10 second, 500 millisecond. That means 10.5 second. Is it okay? Very simple. Any question? Fine?
Yes.
Okay. So now let us do one simple example on packet switching. And if you do exercise 6, then it will cover exercise 5. So I am not doing exercise 5. I am doing exercise 6. What exercise 6 says? There is a scenario where the common, now we are in the packet switching. Keep in mind, we are in the packet switching, but we also try to compare. We will try to compare with circuit switching. So there is a link. Overall link is 200 megabits per second. If we use circuit switching, number of circuit switching users will be NCS. If we use packet switching, number of packet switching users will be NPS. The link capacity is same. And there is one more information. Each user will require 25 Mbps bandwidth. And finally, there is another information. Each user only needs 20% of the time. That means what? That means 80% of the time a user will transmit nothing. So in case of circuit switching, does it matter? Does it matter?
No, sir.
In case
No,
of
sir.
circuit switching,
No, sir.
we dedicate the resource. So it doesn't matter 100% of the time user is using or 20% of the time user is using. The rest of the time it will be idle. That is why it is less utilization. Okay. But in case of packet switching, this will count. That we'll try to understand using this numerical example. Okay, now The first question is very trivial. Shifa Chaudhary, are you there? Okay, Shifa, are you there? No. Okay, when circuit switching is used, what is the maximum number of circuit switch users can be supported? Shahariaz. Shahariaz, are you there?
Yes, sir.
Okay, Khalid Ridwan. Okay, find out. When circuit switching is used, the maximum number of users, what will be the maximum number of users? So for packet switching, let us do exercise 6. Okay, and question A, what will be the maximum number of users? Okay, Yasir Arafat. Yasir Arafat. Sudeep Sarkar.
Yes, sir.
Okay, Sudeep, what is the answer?
Sir, এটা কি স্যার 200 mbps আছে আর এখানে স্যার 25 mbps এটা হলো স্যার 2008 ইউজার হতে পারে।
Right, 200 by 25, right?
জি স্যার।
200 by 25. Okay, maximum, that means number of users, not maximum, number of users in circuit switching will be total bandwidth divided by bandwidth needed by the user. Doesn't matter what percentage of time he or she is active. So answer is 8. Okay. Now see, the circuit switching doesn't count the idle time, that is wastage. Now what about packet switching? For packet switching, we have to, I think, use one formula. Do you know that formula? Binomial. Do you know the binomial formula? So packet switching,
It's a plus b to the power n এরকম।
it is like NCR p to the power r 1 minus p to the power n minus r. You have probability statistics course, right? Completed. Right. So do you know Bernoulli distribution?
Yes,
What is
sir.
Bernoulli distribution? It is like tossing a coin, okay, one time. Bernoulli means either it's tail or head, right? If you do it one time, that is Bernoulli, right? If you do 10 times, that is what? That is binomial. So packet switching uses binomial. So see the application of math. We search for application of math. This is one application of Bernoulli binomial distribution in case of finding the efficiency or usage of internet by the users in using packet switching. So packet switch uses binomial distribution. And what is binomial distribution? Let me write this way: NCR, then p to the power r. Okay, let me write this way to make you understand. No, that will be complicated. NCR p to the power r. Okay, like this way. P to the power, I think it should be now understandable, right? 1 minus p to the power n minus r. Okay, just if you have confusion, go to your probability statistics or search in Google. You will get this. This is not a big deal. This is very trivial, where n is the total number of users, r is the number of users transmitting actively, and p is the probability of a user using internet or not. So in our case, what will be the value of P? Anyone? In this
15,
example,
sir.
what will be the value? No, not 15. It will be 0.2. P is the probability. See what it says?
Correct, sir.
Only needs 20% of the time. That means probability of transmission is what? 0.2. So 1 minus P will be 0.8. Now, how many users packet switch supports? That is the question. How many users packet switch supports? Actually, packet switch will never put any restriction on number of users. So how can we decide? We have to assume, okay, if we use 15 users, then what will happen? If we use 50 users, what will happen? Okay, I think we are out of time today. So in the first part of the class, next class, we'll complete this example, but this example will be included in your class test. So in the first part we complete that, and then we'll go to 1.4 and 1.5. And also, please do all the exercises before this example, and then we will discuss about your problems in the next class. Any question, any short question, just let me call your names. If you have any question, you can ask. Abdullah Al Rifat, Inamul Haq,
Present, sir.
Imam Reza,
Present, sir.
Rukunut Jaman,
Yes, sir.
Laila Ishrat, Farah Farzana. Laila, are you here?
Yes,
Okay.
sir.
Farah Farzana, Fazle Rabbi,
Yes, sir.
Priyo Brato, Nath, Ifat Haq.
Present, sir.
Priyo Brato, are you there? Ifat Haq Rafsana. Okay.
Yes, sir. Present, sir.
Ali Ahmed. Then Khurshida Jahan.
Present, sir.
Samir Ahmed. Mahmudul
sir.
Hassan. Samir, are you there?
Yes, sir.
Okay, Mahmudul Hassan.
Present, sir.
Fahim Shakil.
Present, sir.
Abu Sajjad. Okay, Nibirujjaman.
Present, sir.
Sadman Shakib.
Yes, sir.
Adnan Kabir.
Yes, sir.
Taki Yasir.
Present, sir.
Shahadat is there. Rakibul Islam.
Yes, sir.
Rakibul. Okay. Al Shahriar.
Yes, sir.
Tanvir Hassan. Sakib Hussain.
Yes, sir.
Sakib. Okay. Mashuk Alam. Sabbir Sarkar.
Yes, sir.
Sir, Mashuk Alam, assistant, sir.
Okay, Mashuk Alam. Sabbir Sarkar. Okay. Abrar Sadiq.
Yes, sir.
Ishtiaq Ahmed present. Abdullah Al
Yes,
Mufil.
sir.
Present, sir.
Okay, Mahfuzur Rahman.
Yes, sir.
Shafiqul Al Islam.
Yes, sir.
Amanta Hussain. Abir Reza.
Present, sir.
Khalid Redwan present. Shahriaz.
Present, sir.
I could not find you previously. Okay.
Sir,
alert.
yes, বলছিলাম তো, sir.
Okay. Tahmina Tanjin.
Present, sir.
Mahfuzur Rahman.
Yes, sir.
Fazila Nabi.
Present, sir.
Misbaul Alam.
Yes, sir.
Shifa Chaudhuri absent. Yasir Arafat
Present, sir.
present. I could not find you.
Sir,
Previously.
মাইক লাগানোর সময় লাগাইছি, আপনি তখন অন্যজনকে আস্ক করে ফেলছেন।
Okay. Always be alert in the class. I want everyone to be active in this class. Okay. Sudeep Sarkar present. Abdur Rahim present. Miraj Farooq.
Sir, you didn't call my name.
What's your name? Name, please.
Sir, Ashraful Nahar Ifti.
Yes, Ashraful Nahar present.
Sir,
Actually,
আমার
when
নামও
I
স্যার
call someone during the class and I find present, I will give herself or himself present right that time. Okay. So if you are alert, fine. But if I don't get 2 times, 3 times, then if you at the end of the class you say, okay, I am present, I will not count that. So just be careful. Miraj Farooq.
Yes, sir.
Miraj,
ছিলাম স্যার আপনি প্রেজেন্ট দেন নাই
কে বলছো?
স্যার শফিকুল ইসলাম
স্যার আমন্তা হোসেন প্রেজেন্ট
ইসলাম, আমন্তা। শফিকুল,
স্যার আমার নামটা ডাকা হয়নি স্যার
শফিকুল প্রেজেন্ট।
গত ক্লাসে স্যার দেন নাই স্যার গত ক্লাসে পুরো ছিলাম স্যার প্রেজেন্টও দিছি স্যার কিন্তু আপনার স্যার ইউকেএম এ দেখাইতেছে অ্যাবসেন্ট
Okay. Okay, let me check. Okay, Miraj Farooq. Miraj absent. Abu Abdullah absent. Khandokar Sravon.
Yes, sir.
Okay.
Yes, sir.
Okay, Khandokar Sravon present. Okay. Let me call the absentees again. Abdullah Al Rifat. Farah Farjana.
Yes, sir.
Okay. Priyabrata Nath. Ali Ahmed. Abu Sajjad. Tanvir Hassan. Amanta Hossain present, right?
Yes, sir.
Okay. Any other?
স্যার আমার নামটা ডাকা হয়নি স্যার।
কি নাম?
শাহ আলম।
স্যার ইমতিয়াজ হোসেন শোভন।
শাহ আলম। শাহরিয়াজ।
না স্যার, শাহ আলম।
Shah Alam. What is your ID?
181168
181
168.
18168. I don't find you. You registered late?
Yes, sir.
Okay. 161 181
168.
168. What's your name?
শাহ
Shah
আলম।
Alam.
Yes, sir.
Okay.
স্যার আমি হচ্ছে ইনভাইটেশনটা পাইনি স্যার।
Okay, give me an email. Those who are yet to receive invitation, just give me an email. I'll give you send you invitation again. Okay, any other?
স্যার ইমতিয়াজ হোসেন শোভন।
Imtiaz, what's the ID?
স্যার 143129।
143129. Okay, 14. You also registered late, right?
Yes, sir.
143129. What's the name? Imtiaz?
মোহাম্মদ ইমতিয়াজ হোসেন শোভন।
Muhammad Imtiaz. Okay.
স্যার
Okay, any other?
152054 দিয়েছেন
15
152054
152054. Okay, 152054. You also registered late, I think.
Yes, sir.
What's the name?
স্যার রিফাজ নাহিয়ান
Rifaz Nayan. Okay. Any other? Okay, I think all. Okay, sorry for taking 3-4 minutes more. Thank you. See you in the next class.
থ্যাংক ইউ স্যার
Assalamu alaikum, sir.